Hi, my name is Dr. Tony Curran of the University of Southampton in the UK, one of the academic partners of the Zero Wind project. In this webinar, I'm going to talk about case study 4 of Zero Wind's set of 10 practical demonstrators on developing resource-efficient construction networks in the UK. The construction sector makes an important contribution to the European economy. It also consumes more resources and generates more waste than any other sector. Around 50% of this waste is recycled or reclaimed, and the EU target is to reach 70% by 2020. This case study consisted of 3 construction projects delivered by Wilding Butler Construction, a medium-sized construction contractor based in southern England. There was a progression across the 3 projects so that gradually more zero waste principles could be applied and improvements made. The industrial network of suppliers and markets for surplus materials and wastes was more developed each time. The first site involved preparatory demolition works and the construction of a 4-storey youth development centre in Aldershot, Hampshire. Wilding Butler had no input into the design of the building, which is commonly the case. One innovation that could be implemented was off-site manufacture of the bathroom units. This has lower energy use and waste compared to traditional construction on site. The second project was a preparatory demolition and construction of a new dining hall and offices at a school in Reading, Berkshire. Here, Wilding Butler had a small input into the specification and procurement of some materials and products. Developing the industrial network enabled them to identify inputs with lower resource intensity, such as a carbon-neutral plasterboard product in place of blockwork, which avoided the use of 750 litres of water as cement was no longer required. The third site was a set of 13 residential apartments in Southampton. In this project, Wilding Butler was involved at the planning stage, so could influence the building design and material specifications. Material substitutions were applied for concrete, steel, blocks, bricks and carpet blocks. Once barriers to improvements were identified, steps could be taken to overcome them. Here are a few examples. The client or design team sometimes decide on the construction techniques and materials before the contractor gets involved. Engaging them in a stakeholder network from an early stage can enable more resource-efficient options to be included. Efficient logistics and material management. This covers a range of actions, including reducing over-ordering of materials, requiring take-back of surpluses from suppliers, identifying end markets for wastes that result in higher level recovery. This can also result in reduced emissions from transport. Good practice on site. The use of mixed waste skips can prevent reuse and high-quality recycling. Smaller skips and bespoke bins can be used instead. On-site staff training can highlight simple practices to reduce the amount of energy and water used and correctly segregate material types for later recovery. Enabling reuse avoids waste as well as the production of new products, so this reduces emissions and water use too. In this practical demonstrator, an industrial network was created around each construction project, which allowed both material inputs and surpluses and wastes to be saved. The principles of eco-design and industrial symbiosis were used in developing the networks. Following a thorough life cycle assessment of the data from each site, we can announce that a 58% reduction of greenhouse gas emissions was achieved. 93% of waste was reused or recycled, and 43% less fresh water was used. The zero-in approach of forming resource-efficient construction networks resulted in clear and significant improvements. Thanks for listening.